Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how we find inflection points. In the previous video, we talked about how we can use the first derivative to find what we called maximum and minimum points, or extreme points. And knowing maximum and minimum points of a graph gives us a lot of information. We also learned that we could find where the graph was increasing or decreasing once we found those max-min points. However, we can get more information about a graph if we find what's called inflection points. And to do that, we need to look at the concavity of the curve. So for example, I drew the graph of 4 functions, and all 4 functions are increasing. However, the shape of them is different. We would say that this graph is concave down, and we can see that the growth, or the way that it's increasing, slows down. This graph is increasing, but the rate at which it increases speeds up, and that would be called concave up. It opens up. Concave down means it opens down. This graph starts off concave up, and at some point it switches to concave down. This graph starts at concave down, and at some point switches to concave up. So understanding about concavity and knowing where the graph is concave up or down gives us additional information that allows us to be better at drawing the graph of the function. What we're going to do in this video is find what's called inflection points. That's called an inflection point, where the concavity changes. Although the function is increasing with both of these graphs, the rate at which it's increasing is different. The rate at which this graph is increasing is decreasing, if that makes sense. The rate at which this graph is increasing is increasing. So remember, when we're finding the rate of a rate of change, it's actually the second derivative. So in this case, our second derivative would be negative because it's the rate of change of the rate of change is decreasing. So the second derivative, to show it's decreasing, it would be negative. The second derivative here would be positive because the rate of change of the rate of change is increasing. One way to remember it, if it's concave down, the second derivative is negative. And I just think of that as a frown. Concave down is a frown, and we can think of that as a negative person. On the other hand, concave up is like a smiley face, and that means the second derivative is positive. So smiley face, positive person. But let's take a look at how we actually find inflection points and how we use that information to draw our graph. So the steps for finding the inflection point or points is very similar to the steps that we did in finding max-min points. However, now we're looking at the rate of change of the derivative, or the rate of change of the rate of change. So that means that we're looking at the second derivative. So we're going to find the second derivative, first of all, and I'm going to go through these steps by using this example, which is the example I used in the last video to find max-min point. So to find the second derivative, I first of all find the first derivative. So that's 3x squared minus 4x plus 1. Then I find the second derivative, which is 6x minus 4. And then I set the second derivative equal to 0, and I solve. So I had one value that has a second derivative equal to 0, and that's 2/3. We don't know for sure that that's an inflection point. We need to test it. This time we're testing the second derivative on either side and seeing if it's positive, which is concave up, or negative, concave down. And it needs to change from one to the other as we go through that point. So let's do a test. So since we only have one point, we just have these 2 intervals that we need to check. So we're going to check the second derivative to the left of that point. I'll pick the easiest value, which is 0. The second derivative when x is 0 is -4. So that's less than 0. It's negative. Remember, negative people? It frowns. It's concave down. And then to the right, I'm going to pick a 1. So I'm going to find the value of the second derivative. When x is 1, the second derivative will be positive. So when it's the second derivative is positive, it's concave up. So the concavity did change as we went through that point. So therefore, this is an inflection point because the second derivative at that point is 0 and the sign of the second derivative changed as we went through the point. Then we find the corresponding y value. The y value at x equals 2/3 will be 2/27. So the point 2/3, 2/27 is an inflection point. So the graph of this function looks like this. In the last video, we found the maximum point and the minimum point. And now we found the inflection point. So we can see that it was concave down until this point, and then it switched to concave up, which our number line test showed us. So that just gives us a little bit more information about the graph. Let's take a look at 2 more examples. In my second example, we are going to start off by finding any max min points, and to do so, we find the derivative. We set the derivative equal to 0, and we solve. Then we need to test. Just because the first derivative equals 0 doesn't necessarily mean it's a maximum or a minimum point. A test will tell us what we're dealing with. So we test the first derivative to the left of 0, so we'll pick -1. When we put -1 in our first derivative, it will be positive. So that means the function is increasing in this interval. Then we test the first derivative in this interval. We'll choose 1, put 1 in our first derivative, and we get a positive value as well. So the function is increasing in this interval as well. So this is not a max or minimum point. Let's see if we have any inflection points. So to find inflection points, we take our second derivative. So our second derivative will be 6x. We set that equal to 0, and we solve. So our solution will be x equals 0. Same value here. Just because the second derivative is 0 doesn't necessarily mean it's an inflection point. We have to make sure the concavity changes as we go through the point. So we want to do a test of that point, and we're testing the second derivative. So we're testing the second derivative to the left of 0. We'll pick -1. The second derivative when x is -1 is negative, which means it's concave down. Then we test a number in this interval. We'll choose 1, and we're testing the second derivative. So when we put 1 in, we get a positive second derivative, which means it's concave up. We therefore know that this is an inflection point because the second derivative was 0 at that point, and concavity changed as we went through that point. So our point will be 0. Go back to the original function. When x is 0, y is 0. So 0, 0 is an inflection point. So if we were to draw the graph of this curve, we know that it's increasing over the whole interval, but it's concave down to the inflection point 0, 0. And then it changes to concave up, but it's still increasing. So that's what that graph would look like. And here is our inflection point. Let's take a look at one more example. In our last example, we're going to go through the process again. We're going to find any max min points first by finding the derivative. Set it equal to 0. And I'm going to factor out a 12x squared. And I'll be left with 1 minus x. And we solve. So I'll get a solution if 12x squared is equal to 0, in which case x is equal to 0. I'll get a solution when 1 minus x is equal to 0, in which case x equals 1. We'll do a test. We have 2 points. So we have 3 intervals that we need to test. Let's test at -1. When x is -1, -1 squared is positive. 1 minus a -1 will be positive, so a positive times a positive will be positive. So the function is increasing wherever the first derivative is positive. I'll choose 1/2 as the number to test in this interval. 12 times 1/2 squared is positive. 1 minus 1/2 is positive. A positive times a positive is a positive. So here's a situation where it didn't change. It didn't go from increasing to decreasing. It's still increasing. And then in this interval, I'll choose the number 2. 12 times 2 squared is positive. 1 minus 2 is negative. Positive times a negative is negative. So the function is decreasing. So we know that this is a max point, and this is neither. We'll find the y values once we get all our points. Then we find inflection points by finding the second derivative. So that will be 24x minus 36x squared. Set it equal to 0. And I'm going to factor a 12x out of both terms, and I'll be left with 2 minus 3x. So 12x equals 0 will give me a solution, so x equals 0. And 2 minus 3x equals 0. So 3x equals 2, so x would equal 2/3. We have to test the second derivative on the intervals on either side of these points. So if I have 2 points, I'll have 3 intervals. So I'll choose -1. That's negative, that's positive. A negative times a positive will be negative. So we're testing the second derivative, which talks about concavity. So this interval will be concave down. Let's pick 1/2. So 12 times 1/2 is positive. 2 minus 3/2 is positive. Positive times a positive will be positive, so it'll be concave up. And then let's pick the number 1 in this interval. 12 times 1 is positive. 2 minus 3 is negative. Positive times a negative is negative, so the concavity changed to concave down. So we do know that this is an inflection point, and so is this, because the concavity changed on either side. Now we'll find the corresponding y values, and then we'll draw the graph. So we need to find the y value at those 3 significant points at our max point. So we put 1 into our function. We find y value is 7. So the 0.17 is a max point. At our 2 inflection points, we find the y value. So at x equals 0, we plug 0 in. We find y equals 6. So 0.6 is an inflection point. And at y equals 2/3, we plug that into the function, and we find that y equals 178 over 27. So that's also an inflection point. So if we use those pieces of information, we know that the function is increasing all the way up to the max point, and then it's decreasing. However, we know that the function was concave down up to this point, then it changed to concave up, and then it changed again to concave down. So there's a graph with those 3 significant points: max point, min point, and inflection point. In the next video, I'm going to summarize everything just to give you a little summary to help you remember all of this. But practice these in the meantime, and take care, and we'll see you on the next video.